I'll have no difficulties moving forward. Okay, any questions? So let's start with your questions. Anything you have for me? Anything? Okay, so in that case, we will continue with 5.4 and later on 5.5. So 5.4, it's systems that are nonlinear. Nonlinear systems of equations. We are still talking about two variables. But they're not linear. There are different other types of equations, but non-linear. Okay. We are on page. We do not cover 5.2. We do not cover 5.3 in this class. It's not that I skipped anything. So they are not on the schedule. So let's start on page 587. And would you like to go back to 5.1 with more word problems, or maybe we should do that? Yes, yes.
So fast.
I'm sorry?
I know you're so quick, so let's just do it.
No, I don't want to be quick. I don't want to be quick. So, yes. So let's go back and look at a couple of more problems then. I remember we did a couple, but maybe that's not enough. So let's look at, let's say 79. So we are back. So I'm not starting this just yet. So 79 on page 559. A hotel has 200 rooms. Those with kitchen facilities rent for $100 a night. I'm just want to put K in parentheses, kitchen facilities. And those without, they rent for $80 a night. No kitchen facilities. On one night when the hotel was completely occupied, revenues were $17,000. How many of each type of room does the hotel have? So we know that the hotel has 200 rooms of two different types. One that has a kitchen facility and the other type that does not. And we know that one is rented for 100, the other one for 80 because it has less features.
So would one equation be x plus y equals 200?
Correct.
The other one 80x plus 100y equals 17?
Correct. Very good. So x is the number of rooms with a kitchen or kitchenette, whatever, and y is the number of rooms that rent for $80 a night. Since we have two variables, we need two equations. Indeed, x plus y equals 200, and then 100x plus 80y equals 17,000. So the point I was making here is we always have to be consistent in these equations. We cannot add number of rooms plus number of rooms equals dollars, or we cannot add dollars to dollars and get apples, right? So indeed, these equations are consistent. Number of rooms, number of rooms, number of rooms. Dollars plus dollars equals dollars. So now the problems will never, the word problems will never, I shouldn't say never, but in our case, will not indicate the method to use. You use the method you like. You can use substitution here, you can use elimination here. It doesn't matter. Regardless of the method, I would at least simplify by 10 to make it as easy as possible. So now you tell me what you would like to do. Would you like to solve for x or y in the first equation and replace it in the second? Or would you like to do something else?
Solve for x in the first equation.
That's fine. You want to use substitution. Very good. Okay. So then negative y plus 200. And we have to replace x in the second equation by negative y plus 200. So 10 in parentheses negative y plus 200 plus 8y equals 1700. please don't let me move on. If you have questions or if it's too fast or you need time to copy, please don't, because that's not the purpose here. The purpose is that we discuss at each step of the way what we're trying to do. So obviously I'm going to do what? Yes, we'll distribute and solve for y. It's a linear equation. Please give me y.
Negative 10y plus
Yes,
2000.
plus 2,000 plus 8y equals 1,700. And this here will be negative 2y, and this will be negative 300. So therefore y must be 150. But we know that they add up to 200, so then x cannot be anything but 50. So it appears that the point is 50, 150. You should not trust this because it's very easy to make mistakes. So you should go back and check in the original problem. Yes?
Can you
Victoria?
explain how you got 50?
The sum is 200. And we just determined that y is 150. So that must be 50 from here. So then we go back and check and let me know let me know if this is okay. Of course 50 plus 150 is 200. You don't have to check in the first one, but we have to check in the second one.
That's good.
Good. Should I look for another problem? Is this okay? Is the idea clear?
Yes.
Perfect. We'll have more with nonlinear as well. So when we look at systems of nonlinear equations, we'll have more problems there too. Okay, so now we can go back to section 5.4. On page 587. And let's say we start with substitution. The same methods we're going to apply here, substitution or elimination, but the systems will be different. So here is an example, number 4.
Are you recording?
Yes. Thank you. 2x plus, no, please. Anytime. So y equals x squared plus 6x plus 7. Now remember when we reviewed the notes from last time, we said that when we solve systems of linear equations in 2 variables, these are the 3 possibilities. This is not going to happen here. This is a totally different system. Don't expect this, or this, or this, because these are not lines. This is not a line. This is a quadratic function. So what we know from linear equations, systems of linear equations in 2 variables, does not apply here. Okay? Perfect. So this is a nonlinear, although this is linear, this is a quadratic. So it cannot be linear. So let's take a look. I see that this second equation is already solved for y. So why not? All I have to do is replace y in the first equation by x squared plus 6x plus 7. So then we get 2x plus x squared plus 6x plus 7 plus 5 equals 0 because I already see it's quadratic. So let's take a moment and rearrange this equation. So we move the negative 5 from the right to the left. So let's simplify this equation and combine like terms. And hopefully factor. No one will ask you how to solve this quadratic equation. If you want to use quadratic formula, you can. If you want to use factoring, you can. No one is indicated any particular method here. It's up to you. So it's not difficult to factor. X plus 2, x plus 6. So we get 2 options for x, which was not possible in the previous system. 2 lines, 2 straight lines cannot meet in 2 points. That's not possible. So then indeed we have negative 2 and negative 6, but that's just x, and we have to find y. Well, in order to find y, I have to replace x by negative 2. So this is 4. 4 plus 7 is 11. And this is negative 12. So 11 minus 12 is negative 1. So the first ordered pair where these two, the line and the quadratic function meet, is the first one is -2 comma -1. Now for the second one, this is 36, but this is -36. Yes, plus 7, 7. So the other ordered pair is this. We have not seen this before because it's not possible in linear equations, linear systems, and two linear equations. Any questions? Okay, this was substitution. Could I have eliminated?
Yes.
Yeah, I could have by multiplying this by -1 and then adding, but since this is already solved for y, I would not even think of elimination. Yes? Yeah.
So is it because the degree is 2 that there's going to be 2 points? That
Yes,
intersect?
because this is a quadratic function and the other one is a line.
Yeah.
So it crosses the quadratic function 2 points.
I just didn't know if, like, what if there was a different point that it crosses, but it's because x is carried to the second degree.
Yes, but only because the quadratic function has a minimum and the line crosses twice. It could also touch in 1 point, so it could be tangent and have 1 point. But in this case, it crosses the quadratic function in 2 points. So it's something like this. Or maybe the other way, it doesn't matter, I don't know, I haven't looked at the, since when I solved this, it's going to be a negative slope, so it would have been something, but this was just an example. Okay, should we look at another? Okay, perfect, yes, I completely agree. 14, xy equals 4, and x squared plus y squared equals 8. Okay, there is no way I can use elimination here. The variables have to be the same in order to eliminate. Xy, x squared, y squared, I don't have the same variables. So our only chance here is to use substitution. Which equation and which variable?
Why?
Perfect. Which equation?
First.
Of course. I'm not going to solve and take the square root. That will be too complicated. So indeed, 4 over x. All I have to do now is go back to the second equation and replace y by 4 over x and square. So I have x squared plus what?
16x
Over x squared equals 8. We discussed this a long time ago, and this is not a trivial equation at all. Say it again.
Yeah.
So I have x squared plus 16 over x squared minus 8 equals 0. What type of equation is this? And this should tell you exactly what it is. By the fact that I drew a horizontal line, I know exactly what type of equation is it. Rational indeed. Rational indeed. What is the least common denominator here?
X squared.
Yes, it's the only one. The adjustments, please. Adjustments for the top. This is over 1. This is over 1. I need to multiply.
So multiply
I cannot just copy.
x squared.
X squared indeed.
X
1.
Oh,
And very good. So when we have x to the 4th, I'm going to copy this one next. And I'm going to copy this one next. Because I already want them in descending order. So this is digging really deep. That's why we need to review. That's why I need to review the entire course before the final. And I cannot stress enough, and I mentioned that several times, please every weekend find a time to go back and redo your tests, the previous tests with solutions. You will feel so much better. Yes?
why is it over 1? I feel like I got.
Which one?
The middle one. Why is that over 1? Why is it?
You mean this one?
Yes.
I'm not multiplying by anything. You don't have to write anything.
1 over 16.
It's not a fraction. It's what I multiply the top by, which means nothing. I multiply by 1. The denominator is the same. So this denominator was multiplied by 1 to get this. I have to multiply 16 by 1 to get this.
Oh, I see. So it's a representation. It's not that.
Right,
Yeah,
so
it's
it's
not
not a fraction, it's just a reminder. Yes, it's just a reminder and saying, uh-oh, you multiply the denominator by x squared, you have to multiply the top by x squared. Is this okay?
I accept.
Good. Is everyone okay with this? Yes?
Mm-hmm.
Okay, perfect. So now you have two options. You either say this is a proportion and cross multiply, or you ask yourselves, okay, a fraction is 0. What has to happen for a fraction to be 0?
It's kind of easier. It's got a.
When is a fraction 0? Only when?
Numerator is 0.
Of course. Or cross multiply. X to the 4th minus 8x squared plus 16 must be 0. Exactly. A fraction is 0 only when the top is 0. Very good. So now, again, we have to dig deep.
You can do that method where you could do, like, for example, u equals x squared.
Very good. Substitution method, because this is quadratic in form. Only if this is. If it isn't, then I can exactly. And it is. T squared minus 8t plus 16 equals 0. How do I factor that? You don't have to factor it if you don't want to, but you have to get the solutions. You can use the quadratic formula. Yes, it's an easy one. T minus 4 everything squared. So there are two options, but basically one. What is the option?
4.
Excellent. But now we have to go back because you know this has degree 4, so then we have to have 4 solutions. Very good. So 4 solutions, but these two are the same, and the next two will be the same because this is t equals 4, which means x squared equals 4, and I take the square root, of course. So then we get x equals plus or minus 2. So there will be 4 solutions, but 2 of them are 2 and 2 of them are negative 2. Is this enough? No, because I have to go back to y. So I have y equals 4 over x. So then when x is 2, x equals 2, y equals 2. X equals negative 2, y equals negative 2. So then the solutions, there are 4 solutions, but 2 are the same. So these two are the same, 2, 2, and these two will be the same, negative 2, negative 2. You can write them one more time if you feel like it. 2, 2, negative 2, negative 2. It doesn't mean that we have 4 distinct solutions. We have 2, 2, 2, and 2, negative 2, negative 2. As you see, this is a totally different situation, only because they are not linear. So you can expect a lot more work, right, with these. Okay, should we look at another substitution, or can we move on to elimination?
Move on to elimination.
Are we okay with this?
Can we do one more?
Yes, of course. Do you want me to choose? Okay, let's choose 16. In 16 we have x plus y equals negative 3, and we have x squared plus 2y squared equals 12y plus 18. Even if you asked me to use elimination here, I couldn't. Because the first equation has xy, and the second equation has x squared, y, I won't be able to do anything. I'm sorry? Okay, when I square x plus y, what do I get?
Oh, that's okay. Never mind.
It's x squared plus 2xy plus y squared, and I don't have xy in the second one. So it will be messy. So we won't be able to use elimination. Perfect. So then substitution. Now we have to make a decision. I'm not going to solve the second equation for anything. It's a mess, right? So I'm going to solve the first one, and it doesn't even matter which you solve for. If I solve for you, solve for x or for y, it doesn't matter. So what would you like to solve for? For which one? Which one? Okay, we want to solve for x. Negative y minus 3. it's a better option to solve for x only because there is only one x in here. I don't have, if I solve for y, then I will have to substitute in two terms. But solving for x is the wiser decision. Very good. Well done. So then negative y minus 3 everything squared plus 2y squared minus 12y minus 18 equals 0. I have to square, I have to combine my terms, I have to set it, it's already set equal to 0, and I have to find the two solutions for y because it's quadratic. So what do we write for negative y minus 3 everything squared?
Y squared
Yes,
minus 6y
plus.
plus 6y
Very good.
plus 9.
Plus 9. Very good. 2y squared minus 12y minus 18 equals 0. Excellent job.
Easier.
Yes. 3y squared minus 6y minus 9 equals 0. Let's stop and see if you have any questions here, please.
All I know is that the method you showed us to be able to do that factoring, quote unquote,
Yes.
in your head has made it much easier.
Because both of them are negative, right?
Mhm.
So if both of them are negative and you square, everything will still be positive.
Mhm.
Exactly.
I just have to watch because I said negative 6y instead of positive.
That's okay. Can I make it a little bit warmer in here, or you're okay? Are you comfortable? If you're comfortable, I'm okay.
I live in the old
Yeah, can we find out yeah,
I get used to it.
You know it's going to be very hot and then it's going to come back to cold. I don't know when. Okay. So do we understand this step, everyone?
percent. We got 5 by 3.
Yes, thank you very much. So maybe I should invite you over when I teach this class next.
Oh Lord. You do not want to bring me in there. I'm going to be very disruptive. I'm already disruptive at work.
It's not necessarily a bad thing.
You're keeping everyone on their toes.
Mm-hmm.
I like to spread positivity everywhere I go, even though I'm not a very positive person. So,
Yeah,
It helped me in my work.
but you're not boring. I am boring.
no,
I
you
am.
need-
I
this is-
just.
this is exciting stuff.
Yeah. I just like peace and quiet.
This is exciting stuff right here, you know.
Okay. Good. I'm
One,
happy.
you may not
Just
think
not shouting.
you may not think I won't use it, but I will, especially that compound interest. Woo, girl. But hit these stock markets one day, get that bread.
Okay.
But that's just.
So maybe I should record you,
Oh.
literally, and then just every time my students kind of fall asleep or something, I would just pop up and 30-second little video.
Give them life lessons
It-
and tell them
this-
about passive income. No, they're really
I,
be waking up.
I am going to start doing that. When I see that my students are kind of, it's warm in here and they kind of like,
Just
not paying attention. I will just all of a sudden, boom, boom,
Just-
boom. I am going to do that moving forward.
can't lose, can't
Thank
die.
you. You helped me with this. Okay.
Alright, y equals 3 and negative 1. I mean, yeah.
So we have a 3 and we have a negative 1, which is fine. But remember, we had x equals negative y minus 3. So we have to find the corresponding x values. So yes, indeed, negative 6 with x equals with y equals 3, and negative 2, right? Because with negative 1 with minus in front, this becomes okay. So then we have the solution, and please go back and check. Please, always. So we have the solution negative 6, 3, and we have the solution negative 2, negative 1. Is this clear? So this is something totally different. Okay? So this was another example with substitution in which we could not use elimination. Should we continue with another one, or can we move on to elimination?
On the test, is it just gonna be to solve the equation and you pick the method or do you have to?
Yes, I would ask you just to pick the method you like, but there's one thing, which is 6.1, that you will have to do based on the method that it's indicated. But we haven't gotten to 6.1 yet. But here, for example, if you try to use elimination, you'll never end. You'll never come up with a solution because there is no way you can eliminate. Okay? The variables must be the same. At least two of them. At least x with x or y with y. If they're not the same, if one of them has x squared, and the other one x cubed, there is no way to eliminate because they're not the same. You cannot get the 0. Perfect. Okay, so let's look at elimination then. So here's an example. 22, page 587. And we have 3x squared minus 2y squared equals negative 5. And here we have 2x squared minus y squared equals negative 2. So this particular situation and this problem, you can use both. You could substitute for y squared. You could solve the second equation for y squared and plug it in. So both are possible here. So, however, let's use elimination. Question is, what will you eliminate or add to get rid of? 3 and 2 with x squared or negative 2 with negative 1?
Negative 2 or negative 1?
Right, because it's so much easier if you multiply the second equation by,
Negative 2.
right. Once you multiply the second equation by negative 2, you will be able to eliminate the y squared quite easily. So we have to copy the first equation, 3x squared minus 2y squared equals negative 5, and negative 6x squared plus 2y squared equals 4, and then add those two because they will go away. So we are sticking with the plan.
Wait, hold on.
Negative
It should be
4.
negative 4x squared, right? Negative 2 times 2x squared.
I was like, oh damn, I missed that, man.
My apologies. Sorry. I looked at 3 instead of looking at 2. My apologies. No excuse whatsoever. Sorry. I would have gone back and checked and say, oh. Okay, sorry about that. Yes, of course, negative 2 times 2 is negative 4x. Negative 2 times negative y is positive 2y squared. Y times.
Just making sure we're paying attention, that's all.
No, I wasn't. Honestly, I have to be honest. No, I just. Good. So then we have negative x squared equals negative 1. Or x squared equals 1. Or x equals and x equals. And we know what that means. Right, so 1 or negative 1. So now we have to determine y, corresponding to each. It doesn't matter where we go back. So let's go back, let's say, to the second equation. So we have 2 minus y squared equals negative 2. Or negative 1 y squared equals negative 4. And, of course, y squared equals 4. So then we have two options for y. Very good, awesome, thank you. But now I have to be very careful. When x was 1, what did we get?
Both of them.
Exactly. When x is negative 1, what did we get? So it happens that in this situation, there are 4 solutions. Questions? Questions, please. Okay, so let's choose another, or we'll choose from the problems that do not indicate the method, and then we'll have a discussion and we'll decide which one. Do we get the idea? So the variables have to be the same, x squared, or xx, or x cubed, for the substitution to work. At least for one of them. Okay, for the elimination to work, I meant. Okay, so let's take a look at 40. It's on the next page, 588. And we have x minus 1 squared plus y plus 1 squared equals 5. and 2x minus y equals 3. And you will tell me which method would you attempt or even think of applying and which one never. Right, we can't eliminate. There is nothing to eliminate. The variables are not the same. So obviously this is not going to work. Very good. Perfect.
Blacked out, I was like,
So now let's decide what to eliminate. What to solve for, I meant to say.
oh, I was completely joking on that elimination part. Like, I was like, nah.
So of course for y. So I'm going to move y and I'm going to move 3. So then y equals 2x minus 3. In the second equation, I will replace y by the quantity 2x minus 3. Is everyone with me? Good. So then x minus 1 squared plus 2x minus 3 plus 1 squared equals 5. Okay. So, of course, I have to square. This is nothing else but 2x minus 2 squared. So please give me x minus 1 squared.
X squared, and this is plus, or no, it's minus 2, x plus 1.
Excellent. Plus this squared
4x squared,
minus 2 times 2 times 2. 2 times 2 times 2.
it's
X
8x
plus,
4.
very good, minus 5 equals 0. Awesome. So every time we square a binomial, we have to get 3 terms. So when we squared x minus 1 squared, we got x squared minus 2 times the first times the second plus the second term squared. The same thing with 2x minus 2. First term squared, 4x squared. Minus 2 times 2 is minus 8x. And then plus the second term squared and minus 5. And now we will combine like terms and arrange everything in descending order. 5x squared minus 10x. Oh, I love this. Here's why I love it. Quadratic equations that do not have the last term or the free term are the easiest to solve. Can be easier than this. Of course, I will divide and simplify not by x ever, but by exactly. So to simplify this and get x squared minus 2x equals 0, and this is just the easiest type of equation anyone can find or come across. There's nothing easier. Because you're going to factor out the greatest common factor and you're getting 0 and 2 and you're done. If the third term is there, there is always a problem, right? So, quote unquote. It's not as easy as this one. I have to think of special products or who knows, other methods. But here, just the greatest common factor. This is good, but it's not good enough because I have to go back with y equals 2x minus 3 and determine the corresponding y's. When I plug in 0, I get negative 3. When I plug in 2, I get 1. So there are 2 ordered pairs. Can anyone give us those 2 ordered pairs?
0 and negative 3.
Right, indeed, 0, negative 3,
2.
and 2 and 1. Perfect. So in this particular situation, the method was not indicated. We're told, solve. Use the method you like. But we had no choice. We had no choice here. Can we look at a word problem now? With a system that is not linear system. Okay. The area of a rock, 60 on page 588. Any questions for me before we continue? Any questions? Okay, the area of a rock is 108 square feet. And the length of its diagonal, okay, so we're assuming that this is the situation. The length of its diagonal is 15 feet. Find the length and the width of the rock. How many unknowns are in the problem? Or variables if you want? 2. So one is, let's say, the length and the other one is the width. How many equations we have to come up with in order to solve this system? 2, because we have 2 variables, we need 2 equations. If we have 10 variables, we need 10 equations. Perfect. Okay then, so next step.
A squared plus B squared equals C squared.
Excellent.
I remember this one, but yeah,
X squared plus y squared equals 15 squared. This is the Pythagorean theorem. In which I don't want you to remember it as a squared plus b squared equals c squared. I want you to remember it as the sum of the legs squared equals the longest side squared. Because it's not
Triangle.
a squared plus b squared equals c squared. You get my point?
Mm-hmm.
Is this leg squared plus the other leg squared equals the hypotenuse squared? But you're right. So, because I think in high school they teach that the legs are denoted by A and B. But that's silly, because they may not be denoted by A and B. They may be denoted by X and Y. And then what do? You understand my point? But I understand exactly what you mean. Is this clear? So the sum of the squares of the legs equals the longest side squared, not the other way around. It's not 15 squared plus y squared equals x squared. This is where the right angle is. This is leg, this is leg. The sum of the squares of the legs equals the hypotenuse, which is the longest side of the triangle squared.
Can you technically reduce the equation of
No, because we cannot take the square of a sum.
no, we can't take the zeros.
Good. I need the second equation.
X times xy equals 1.
Very good. Excellent. So now we are back to that kind of complicated situation, right? We cannot eliminate. We wish we could, but we can't. So our only chance is to solve the second equation for one or the other and plug it back in. And it's a long process. We're going to get 4 solutions, blah, 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 right? So it's not an easy situation. Good. So I'm ready. Tell me what to do.
Solve for x.
So we will plug in the first equation. We'll replace x by 108 over y, everything squared, plus y squared, and this is 225. So what happens next?
You square the top.
Yes.
And the bottom.
Yes.
I cannot do 108 squared.
I cannot either, and I'm lazy today. I have no excuse. 11664 divided by y squared plus y squared minus 225 equals 0. Okay, now what? Once I correctly identify the type of equation, which is right, I will find the
Least common.
right. If you remember a long time ago when we started this course, I said this is one of the most difficult types. Even my calculus classes have difficulties in solving rational equations. Good. So then y squared is the least common denominator. Now I need 3 adjustments. The adjustment for the top of the first one. 1 or nothing. You don't have to write anything if you don't want to. For the second one. Awesome. For the last one. Right. Because these are over 1. Indeed. So now can anyone give us the top in descending order? You don't have to do it in one step, but if you can, I'd like to write it in one step, in descending order. To the 4th.
Yeah.
Excellent.
Minus 225 squared plus 11.
Excellent. That's the correct sequence. Do you have to do it in one step? No. You can just write it and then rearrange it. Now you have 2 options. You either put 0 over 1 and cross multiply, and what is the other option? Just thinking. A fraction is 0. what has to happen for a fraction to be 0? Only the numerator, because if the denominator is 0, the fraction is undefined. It's not possible, ever. So it's 0 only when the numerator is 0. Yes, the same thing. Yes, it's long. How many solutions do you expect to get? Yeah, because the polynomial has, the top polynomial has degree 4. So y to the 4th minus 225 y squared plus 11,606 equals 0. Okay, so we see again that this is quadratic in form. It is quadratic in form because I was able to replace y squared by t, and the first term has t squared in it. So this is t squared minus 225t plus 11664. I'm not going to factor this. Even if it's factored, I couldn't care less. So I'll use the quadratic formula. Negative b plus or minus b squared minus 4 times a times c over 2a. So let's put it in the graphing calculator. And yep, here it is. I normally don't choose this. Very rarely I choose the same problem.
Well, I was saying
choose
that
the same problem with the class.
I was saying that the answers are at least even. They're not long decimal.
Right.
Answers.
Right. So we do have t equals 144 and t equals 81. After we plug, be very careful how you plug it in. Remember, when you plug it in, you have to have parentheses here, especially if you have an older calculator like I do, and parentheses here, especially if you have a calculator like I do. In the more sophisticated ones, this one maybe you don't need it, but
Could you pull up how you typed it in on the thing?
Yes,
real quick?
of course. Let's do it one more time. You want me to start from scratch?
I just wanted to see how you, as long as I see.
Yeah, so that's what I was
I-
showing on paper. So you need parentheses. This software does not need parentheses under the square root,
Mhm.
but I'm showing this for everyone with any type of calculator, so I don't want you to make an error. So it is mandatory for some calculators to put parentheses under the square root and parentheses outside at the top. Why didn't I put parentheses in the denominator? It's because I only have one term.
Yeah. Okay.
Or maybe only just one factor. So if I had, for example, 2 times 3 times 4, I would have had to put in parentheses as well. So then we got the t equals 81 and t equals 144. But this is another equation, and this is another equation. Which equation?
X.
Yes, y squared.
Or Y squared.
Yes, indeed. So this is y squared equals 81, and this is y squared 144. And this is how we get those 4 solutions. Very good. Y equals plus or minus 9, and y equals plus or minus, this is 12. Correct. So now, the thing is, we're talking about length and width.
So it can't be a negative.
Right. So I will say only y equals 9 and only y equals 12. And then I go back to x, because we have not solved for x. So here's x. X was 108 over y. So 108 over y. So for this x equals 12, and for this y, x equals 9. So you could say there are 2 ordered pairs, sort of. So 12, 9, and 9, 12. It doesn't really matter, right? If a rod has dimensions, although there are 2 possibilities, the length to be 9 and the width to be 12 and the length to be, but the length has to be longer, the longer side, right? So I wouldn't say that there are 2 different situations here. Any questions on, or if you would like us to find more problems with nonlinear systems? If not, we'll move on to 5.5. Yes, of course. Let's find another. Okay. 46. on page 588. The difference between the squares of two numbers is 5. No, you don't. The difference of the squares of two numbers is 5. Perfect. Let's read on. Twice the square of the second number, twice the square of the second number, subtracted from 3 times the square of the first, I'll read it several times, is 19.
I don't think that's English.
Is 19. So that I know for sure. It says is, has to be equal symbol. 19 is 19. Let's read one more time. Twice the square of the second number. What does that mean?
The second
Twice.
one.
Excellent. Subtracted from, but minus in front. Twice the square of the second number subtracted from 3 times the square of the first one. That's it. Variables are the same. I see coefficients of 1 or -1. You can use any method you like. You could use substitution or you could use elimination. It doesn't matter. Let's use elimination. Which variable would you like to eliminate? You would like to eliminate y squared. Perfect. So then we multiply the first one, both sides by?
-2.
Very good. Awesome. So let's copy the first one. After we multiply by -2, and hopefully this time I'm not going to multiply something else. Keep an eye on what I'm doing. So -2x squared plus 2y squared equals -10, and 3x squared minus 2y squared equals 19. So make sure I multiplied the first. So -2x squared plus 2y squared equals -10. So we are on task because as expected, and as we planned, not expected, as we planned we got rid of y squared. And now I add term by term, and I get x squared equals 9. Quite nice, because x squared equals 9 means x equals plus or minus 3 indeed. Now I have to go back to the system because I only determined x, so I have to determine y. So with x squared, which is 9, I replace 9 minus y squared equals 5, or negative y squared equals -4, or y squared equals 4. Which-
Would it be negative x squared?
Which one?
Oh, never mind, I was reading wrong. I thought it was 2x squared minus 3x squared.
Okay, very good. Is that okay?
Mm.
Perfect. So then we have y equals plus or minus 2. But again, when we have x equals 3, we have 2 options for y. When we have x equals -3, we have 2 options for y. So then, can anyone give us the solutions here?
3, 2.
Yes, 3, 2, and 3, -2, and -3, 2, and -3, -2. All these work in the original problem. Any questions?